I have to say I'm really excited to give this in Texas. I used to live in Texas before taking a job with EDF. And the best part about Texas is not the barbecue or the lack of state income taxes, but it's the ability to use the word y'all in any setting, professional or social, and not be judged for it. So I hope you all enjoy the presentation. My name is Brad. I'm an engineer. I use Tableau. And my presentation is called Visualizing a Clean Energy Future at EDF Renewable Energy. And yes, I came up with that myself. So they gave me a hashtag too. I'm going to use this laser pointer and give it a try here. There we go. Hashtag EDF data. I'm not on the Twitter, but if you do like the presentation, I'd be flattered if you tweeted about it. So thank you. First, I'll give you a brief outline of my talk. I'll bring you into the world of EDF Renewable Energy and also our parent company, EDF. And then I'll get into really what our core data is. What do we do with data at EDF Renewable Energy? What type of data we collect? And then give you a perspective of why we collect that data. So I'm going to give you kind of a glimpse into the dirty side of renewable energy. I'm not going to give you the altruistic, feeling about it, but we use data to fix problems. We have power plants, things break, things go wrong. We need data to address those issues. And that's going to be the heart of the presentation, specifically with a focus on wind power, which is about 90% of our business. I'll then get into our data platforms and really how we're using Tableau and our journey into adopting Tableau. Finally, I'll get to the fun part, show you a few of our new dashboards we're designing now, show you some of the cost savings and success stories we've had with Tableau adoption, and give you an idea of what we want to do next with the tool. So EDF Renewable Energy, or EDF-RE as it's branded. So this is going to be really confusing, but EDF Renewable Energy is a North American subsidiary of the EDF Group. Now, the EDF Group is one of the largest producers of electricity in the world, and it's primarily owned by the French government. However, there's a private side, and they do strategic investments all over the globe in terms of energy. And EDF Renewable Energy focuses strictly on renewable energy development and operation in North America. And as a part of that company, we also have a services company, EDF Renewable Services. And the difference there is they will focus their core business around providing services to renewable power plants we don't necessarily own. And by services, I typically mean technicians on site that can maintain the turbines, but also now venturing into data services, perhaps even using Tableau, as I'll get into. So we are the largest North American third-party provider of services to renewable power plants. The global headquarters of EDF is in Paris, and the North American headquarters is in San Diego. And this, I don't know if you can tell, this is actually a live feed. It never changes. This is how it looks every single day. And apparently I've heard some rumors about Tableau in San Diego next year, but I'm going to shut my mouth before I get in trouble. Looking at our portfolio, North America, so the cool thing about EDF is that they work across the value chain or the business cycle for renewable energy. We develop projects, then we either divest them or we maintain ownership in them, and then we also operate projects that we don't own. So we've developed about 8 gigawatts, and currently we own about 4 of those gigawatts, and then we provide some level of a service to 10 more gigawatts of renewable plants. So gigawatt, to give you perspective, if you look at what we impact now between ownership and operation, that's about 15 gigawatts. That's about 3.5 million homes worth of electricity. So it's EDF has a substantial role in impacting consumption in the States. And renewables on the whole has a substantial role. If you look at all renewable consumption last year, it was approximately 10% if you include hydro in that. So it's a large industry, and it's been really going towards kind of data analytics and BI in the past 2 to 3 years. It's really grown up, and that part of the industry has matured. So venturing into now the data aspects, I want to give you an idea. Obviously, 15 gigawatts, we're on the verge of collecting lots of different data from lots of different types of assets, lots of different types of power plants, and it's an incredible challenge to take all that data on site and bring it into a corporate environment for users to digest. So I like to start by just saying, when I'm talking about what data we use, that data is a means to an end, right? Data is not our business. It's not the end. The end for EDF, renewable energy, is to own and operate efficiently run power plants. Now, we need data to do that, but it's not our business in itself. And I think it's important to make that distinction because, especially at conferences like these, it can be overwhelming, and a business can over-divulge and over-invest in, BI, warehouse, IoT, blah, 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 all these buzzwords of solutions, and they're really slick and they're really cool, but still the only thing intelligent about a business is its employees. So unless you have tools that you integrate and really empower your employees to make decisions, unless we're using our tools to actually impact our assets, then we're just wasting money. And the one prop I'll give Tableau is that it's been fairly seamless to integrate into our organization because it's such an easy tool to use. So people inherently just want to use it and understand. So it's been really helpful to leverage a platform like Tableau. And now besides Tableau, we have a lot of other types of tools that we look at data. Specifically, some of those tools are more operations-based that looked at real-time data. This is actually a picture of our operation and control center in San Diego. So this is responsible for the day-to-day, hour-to-hour, second-to-second monitoring of all our renewable assets in North America. And they look at all types of real-time data, and not necessarily with Tableau, but just to give you perspective, we do go even outside of Tableau. So that's really the first use case, is really the real-time monitoring, the operation control center, where they need to know what turbines are down or what solar panels are not working, why they're not working, how long they've been down, whether or not they have control to restart them, to get them up and running again. That's really a major use case for us to do that real-time aspect. The other aspect is really where the group I work for comes into play and where Tableau comes into play. And that's taking all this real-time data, aggregating it in a warehouse or some type of solution, and then doing the historical analytics and trending on the data to discover more long-term trends in plant performance, perhaps to discover more subtle reasons why the assets are underperforming, and do engineering root cause studies. Ultimately, we are engineers, and our job is to fix things, and Tableau has been handy in that. The third aspect, which I won't get into much today, is then venturing into the predictive sides of things. So pairing all that historical data and saying, well, I know now the load cycle on this asset over 5 years. I'm going to predict that this gearbox or this component is going to fail 6 months from now or 8 months from now. And we have some tools to do that. We haven't really dabbled in Tableau much about that. For the presentation, just because there's so much focus on, I'm largely going to be addressing number 2 because that's kind of what I do a lot with our group. And there's only so much to talk about anyway. So if we boil down that number 2, what we really do at Tableau, what the engineers are responsible. We're basically responsible for 3 questions, answering 3 questions we get on a daily basis. And they are, what went wrong? How much money did I lose? And can I fix it? So unless we have tools that quickly turn around these questions into answers, we're not doing our jobs. And these are the questions that we try to answer with Tableau. Now, getting into these questions a little bit more, I want to introduce you to what can go wrong, specifically in a renewable power plant, specifically in a wind power plant. And this is kind of the dirty side that you might not see, but we need to talk about it because these turbines are extremely complex electromechanical designs, right? For instance, the most installed unit in North America is a GE 1.5 megawatt turbine. That turbine weighs 164 tons. Its rotor diameter, the swept circular diameter, is about 80 meters, which is more or less a football field. If we were to look at the newest generation of turbines, they're about double that. The Vestas V164 has a 164-meter rotor. The blade, each individual blade, is about a football field. So these are massive structures. And the reason why they're getting bigger is because the amount of electricity we can produce is proportional to the size of the rotor. the more incoming wind energy we can capture. So there's economics to why they're growing. Besides that, once essentially the wind hits the rotor, which is essentially 3 airplane wings, which spins, we then transfer that rotational motion through a gearbox, basically to turn a generator, and voila, we have electricity. Besides that, though, we have a lot of other major components that are responsible for controlling the turbine. So for example, we have wind vanes and anemometers up here to measure the wind direction and how fast the wind is blowing. We have a yaw drive down here. So basically, when the wind direction changes, the turbine also needs to pivot so that we're always facing the wind. We also have pitch motors, and these are responsible for feathering the blades because we need to feather the blades with respect to wind speed to produce the most power, to be at our optimal set point, if you will. So all these systems are then controlled by kind of a master CPU controller, and because there's so much mass and so many moving parts, we have reliability issues. Things do break. So when things do break, the turbine goes down, and that means it's an opportunity cost for us because the turbine could be spinning, we could be generating revenue, and ultimately measuring that opportunity cost is pivotal for us to prioritize what problems we can fix. We want to prioritize the reasons why we lose the most energy. So I just want to give you a brief introduction onto why we lose the energy. We're ultimately responsible for categorizing these root causes of lost energy and lost revenue. So the first cause is more or less turbine issues, turbine-centric issues. One type of turbine issue is just a fault. Think of this as a check engine light. A component got too hot, something spiked in terms of voltage in the turbine, and it's more or less a safety shutdown of the turbine. So we'll go down and we'll lose energy because of that. The other type of turbine downtime is more scheduled. It's a tune-up. It's a scheduled maintenance where we have techs that biannually will climb the tower 300 feet in the air and do standard procedures to ensure that the turbine is operating at its maximum. The third, more or less, type of downtime for a turbine is unscheduled. It's a repair. That's typically when one of those major components I just went over will break, and we have to procure a new part, perhaps wait for that part to come to site, perhaps lift the whole nacelle or whole rotor off the machine. So this is really the most costly type of downtime for us because the turbine could be down for days on end. So these unscheduled repairs are things we look to minimize, obviously. Now, besides turbine reliability issues, we have a whole power plant. So we have components outside the turbine that are responsible for carrying the electricity onto the grid. So we have underground collection cables connecting all the turbines. We have transformers that step up the voltage to get it onto the grid. And we have substations and meters and all that. And all that can go, a component there can go wrong as well. And that's actually critical because when a balance of plant component, as we call it, goes down, it could take down a whole string of turbines or even the entire site. So these are major events that could cause us thousands of dollars of revenue, and it's critical that we're looking at data to minimize that. The other type of outage is really an outage or a shutdown that we can't control. This is an external command that the utility might send us. This is known as curtailment in our industry. So to give you a perspective or example, sometimes in the Midwest, there might be too much congestion on the grid. There may be too many wind farms in one area. For stability purposes, the grid is not designed to operate with that much load on it, and the utility will say, hey, we know the wind is blowing, we know you could produce X amount, but we're going to need you to limit your power because we can't handle it. And that's actually really important for us to measure because contractually we typically have agreements with the utility that we are able to get reimbursed for those types of losses. So that's a big use case for data for us to make sure that we're accounting for times where we're curtailed. Besides turbines going down, we're also interested in how they're performing when they're online. This is a big piece because turbines are usually operating and they're usually online. So what I'm showing here is a very common view, perhaps the most common view in wind energy. It's the power curve view. So this black reference line is essentially the way the turbine should be performing from the OEM. So this is a brochure power curve. The x-axis here is wind speed. The y-axis here is active power in kilowatts. So you can see as the wind speed increases, we should be producing more power up to the rated capacity of the generator. And you can see in most of our blue operational points, which are 10-minute average data, for the most part, we do follow the reference curve. However, there are times, as you can see in our algorithm here, that the turbine will self-limit its own power, perhaps again because a warning active on the turbine, a component got too hot, perhaps the wind direction's changing too rapidly, or the wind field is too turbulent and the turbine senses it's under too much load. So there's all types of reasons why the turbine could limit its power, and we need to be able to catch these, flag these, measure how much money we've lost, and then provide, again, corrective actions if possible. And finally, I will get to my favorite thing that can go wrong in a wind plant. And this, again, is mostly stuff we can't control. Icing, extreme weather. So we have 9 projects now that we have some type of ownership in Canada. It's an extremely large event in Canada for ice to accumulate on the blades and sometimes completely shut down the turbine, or the turbine will sense it has ice on its blades and not run at all. And that could be for hours or days at a time in extreme climates. Or in some cases, there could be ice, small amounts of ice on the blade. The turbine will still be operating, but you can see if you look at that power curve view in this light blue region, this turquoise region, there's a classic signature of underperformance when ice is forming on the blades. It's because it's disrupting the airflow, it's disrupting the amount of lift and thus energy the turbine can produce. The other real interesting extreme event is lightning. So these turbines go hundreds of feet into the air, and lightning strikes are fairly common at our sites. My buddy John here is a lightning expert. He recently went to a lightning conference, so ask him any questions you have about it. But this is what I would say is a catastrophic event where the blade completely had an internal failure. A lot of the times lightning can be a little bit more subtle. So these turbines do have lightning protection systems embedded in them to channel the current to ground, but sometimes it might not go through the right channel, the spar could be damaged, and the blade will fail entirely. So now that you're an expert into everything that can go wrong, I will show you how we're measuring how much money we've lost from all that. I'm sorry, I'm an engineer, so inherently I'm a pessimist, right? So this is essentially our current system of collecting data in terms of getting into Tableau. Really, the largest source of data for us is the asset itself. So these assets have hundreds of sensors on them, collecting real-time information about the ambient conditions, internal temperatures, how fast the wind is blowing, how much electricity they're producing. We collect this in real time and bring it in to our OCC field network and visualize it in our OCC. This helps them, again, do the real-time control aspect so they can reset turbines, they can see which ones are down in real time, and to take care of that kind of hour-to-hour type operation. We also take that real-time data and we identify really the critical data that we need to do BI, quote-unquote, on. So it's really only 1% to 2% of our total data. I mean, we record about 1 billion data points a day. And we really only need a small percentage of that to do most of our traditional BI analytics work. So we take the data and we aggregate it over 10 minutes into 10-minute statistics, which is the industry average, and we throw it into a SQL server. And basically from there, we have all the static data about the project in SQL Server as well. So that's when you can start to mix the sensor data with the static data about the asset and start to do your first kind of level BI. And that's really how we got started. We would leverage Tableau and SQL Server, either with live connections or with extracts, and we'd start doing ad hoc engineering studies, typically in desktop. And as we kind of matured, we realized we needed more data sources, not just the sensor data, but also just maybe web sources of data or just other things that could create a full picture for an asset manager. So our internal customer is really the site manager or the asset manager that can make decisions about the operation of the plant. So we need to serve them up kind of the complete picture. And to do that, we incorporated some more data, one being a weather forecasting service that we pull into SQL Server with some Python scripting. And also another very important piece, especially here in Texas, is market data. So in some of our older projects, we would have a fixed price that we would sell into, a PPA, power purchase agreement. But for a lot of the newer projects, we're actually selling electricity into a market, which has stochastic variations in the market price. So really, if I'm, as an engineer, trying to estimate how much money that we're losing from a turbine being down, I need to pair the sensor data with that real-time pricing data to say, this turbine was down at 9 a.m. because of that. The price at 9 a.m. was this. You've lost this much money. So that's a very critical piece that we just integrated into kind of our overall data warehouse. The other aspect, which I won't talk about much today, is we also use Tableau to connect to SAP. And SAP is more of the transactional data for us. So for example, when a tech visits a turbine and performs labor hours, they need to log that. They need to log, if they need a new part or what the inventory of the part is. We track all that data in SAP. So that's another aspect of the BI, which is a little bit standalone right now, but we're really working on truly integrating it all in the next year. So this is kind of where we're at right now, and it gives us most of the answers. We're still working very hard to really pare down even more data. But it took a while to get there. So I wanted to give you an impression if your company is looking to adopt Tableau or just do more analytics in general. Really in 2012, we didn't have much, I would say EDF Renewable Energy didn't have much experience doing analytics or working with a lot of BI type tools. And the first thing they did, which was the right thing to do, is to try to get the right people on board to ramp up your engineering teams and your IT team. So really in late 2012 is when we started kind of getting the people on board. In 2013, the OCC in San Diego was open, so that was a big kind of landmark thing for EDF. And also, as an engineering group, we started using Tableau Desktop to do kind of ad hoc engineering studies, just connecting to data, playing around with it, finding a few turbines here and there that are broken. At this stage, though, we still had some pretty angry internal customers because, as an asset manager or a site manager, they want, everything all at once, and they want it now. They want it updated, and they want, an enterprise solution. And we weren't quite there yet. They were seeing that we were getting there, but we weren't quite there yet. So in 2014, we really decided then to build the data warehouse and then to also invest in Tableau Server so that we could host our analysis up in a seamless way and we could share them across the enterprise. So that's 2014 is when we really first got our quote unquote larger scale adoption or wide scale adoption. I don't know, I'm not good with the IT buzzwords here. 2015, we got a lot better. We started designing our second generation of enterprise dashboards, performed a lot better. We also started integrating SAP into Tableau and creating dashboards with SAP data about service orders and parts usage on site. And really at this point today, we're doing analytics internally for the projects we own, but we're also offering dashboarding and analytics to third-party wind farms that we don't own as a service. And we're just kind of releasing that, and the marketing team branded it as Truelytics. So yeah, I have nothing else to say about it, but no, it's sometimes tough to pronounce. So I'll show you if I can get this to play. It's actually a really cool video that kind of ties it all together. And my boss is in it right over there, so I like to embarrass
Imagine
him.
a project recently going COD. It would be reasonable to assume that the turbines are performing as prescribed or as promised from the OEM. And then only after some months do you become aware of some power curve shortfalls, maybe some unintentional curtailments that are taking place. Only after then do you realize that you've lost or left a significant amount of revenue on the table.
When you're managing assets, you're managing a lot of compliances, contracts, relationships. You are making sure that the assets are performing well. When I get frustrated because the data is just stale and it takes forever to review and analyze, it's overwhelming.
It used to be that you would spend 50 to 90% of your time collecting data and then the residual amount of time analyzing it. We're striving to flip that to where it's 90% of your time is spent interpreting the data and gaining insights that you wouldn't have otherwise had. Imagine if you could blend in one interface all of your data sources to piece together one complete and holistic view of your assets. including budgets, operating expenses, turbine performance, turbine reliability, weather forecasts.
Tools are critical because if you have the right softwares, if you know that your people know how to access them, it makes their job faster and easier.
We were able to unveil key issues and insights that otherwise would have been hidden from us. We accomplished things that would have normally taken us days or weeks to do. There's plenty of other companies out there that offer turbine visualization. We differ in that we can take disparate data sources and blend them in with the operational data to tell a more complete story.
I am more self-sufficient. You can make better decisions. You can make quicker decisions.
This platform will help to make informed decisions. We can stop assuming. We can start knowing.
Seriously, it brings a tear to my eye every time. And I guess I've been watching some wrestling videos on YouTube. You just wake up in the middle of the night sometimes, you just want to like, oh, I just want to watch old WWF videos. It's funny. So, okay. So yeah, I'll show you some of the new stuff that we're putting into that now. How about that? Fire alarm, huh? Let's freeze that. All right, let's unfreeze it. So right now, this is hosted on Tableau Online right now. This is actual data from one of our projects year to date. And to give you a perspective, this is one of our new dashboards. It's our budget tracker. So what you're seeing is 4 different views comparing production, both in terms of energy or revenue, depending on what the user selects here, versus the budget. And this is for one project. You have a project drop down here. So this project, Project D, which is in California actually, you have a month-to-month variation of your, is this working? Of your actual versus your budget in black. The one thing to note for wind is that wind is a variable resource, right? We don't control the wind speed. We budget on a monthly basis. And for this project, just because of where it's at, we expect higher wind speeds in the summer, which is why you see it kind of peak out and then die down in the winter months. That's just how this climate is based for wind. So you have each month here, then you have a cumulative year-to-date here. The one thing you'll know is with all our designs, we try to make our tooltips plain English, dynamic text to really tell the user and verbalize to the user what they're seeing. So when they scroll over, okay, production revenue for this is this amount, which was 22.6% lower than the budget. So it's kind of common sense, which is a hit for our asset managers. Down here, then, you'll see a more tabular, classic view of the data because our asset managers were kind of used to looking at tabular reports. So all this is tied in with actions to the above views. So you can see the highlight actions as you click a month. And probably the coolest view that I like about this one is this daily tracker here. So what you're seeing in here is every day of the year, green bar signifying if we were above budget that day, red bar signifying if we were below budget that day. And if you scroll over the marks, you'll see the wind speed as well, how much above or below budget you were on that specific day. Now, the one last piece is all these icons down here. So to note, for wind, again, if you're, what typically drives the majority of the budget is if the wind speed was above average or below average that day. If you have a windy day, you're probably going to make your budget. If you don't have a windy day, you're probably not. However, because of these reliability issues I introduced you to, these operational inefficiencies, sometimes we can still have high wind days but not hit budget, and that's because turbines will go down. So what we've tried to do with these icons is signify days that you had a lot of turbines down or you had a lot of efficiencies, and the user can control them with these 2 parameters over here. So for example, you see a lot of these icons pop up in March. So if we were to just scroll over March and click it, we've filter actions here, filter for this month only, and that zooms in to your daily tracker in March. So now you can see all the days and days that you had issues and what those issues are. So basically this turbine means that you had a lot of turbine reliability issues that day. The grid icon means that you had a BOP or a grid-related shutdown. Curtailment is you had the utility saying that you couldn't produce as much as you could that day. So these are the top sources of losses that day that met the threshold. So then if the user or the asset manager really wants to get detailed, and they really want more information about this day, we can then drill down on this day, which goes to our event tracker dashboard. So if you click this, this will bring us to a completely new dashboard, an event tracker, which looks at now data at a turbine granularity. So this is saying here what your top 10 most costly issues were this day and the root cause of these issues with an icon. So you can see that this icon is a scheduled maintenance icon. So you can see that there were a series of turbines that underwent just a typical scheduled maintenance this day. And you can actually visualize these on the map over here of the site, and you can see the techs visited this portion of the site that day, and they visited all these turbines. This is how much money you lost because of scheduled maintenance that day. If you even want to get more detailed, what time of day did you do the maintenance? You can switch over to our kind of Gantt chart or timeline view. This will now show you all the turbines which they have accrued losses and the hours of the day they were down, and you can scroll over them to get more information. So now with a few clicks, we've gone from project level information for an entire year down to a monthly drill down to a daily drill down, now looking at hourly data, specifically what minutes of the day the turbines were down, how much money you've lost. And this is actually my proudest moment as a Tableau developer. I don't know if you guys caught this, but we're on the same dashboard and we're selecting what view to look at in the dashboard. It's called a pop and swap. It's on Google. It took me about a half day to do, but it's seriously, like, I'm still like amazed that I got this done. I could do this all day. The other aspect of this dashboard, if you just wanted to stay on here, is looking at how much revenue losses you had every single day of the year. So obviously, as an asset manager, you want to look at the spikes. Where are the days that I lost the most money and why? So you can just stay on this dashboard, navigate, say, to one of these days, say August 31st, filter the event list, and now you're just moving this report to August 31st. And you can see on this day, there is a large BOP type event which affected that cluster of turbines. So perhaps an underground cable went down. If you wanted to see what exact turbines were down, you can then change the aggregation variable. If you wanted to see losses by turbine, all you have to do then is switch that, and you can see these were the turbines affected by that outage. So we're trying to give as many different aggregations possible in one kind of data visualization. So there's one other dashboard I should probably show you, which is pretty cool. It's the power curve dashboard. So let's switch to another project, and this is showing that project that day. But let's go to our power curve tracker dashboard. So we have buttons up here where you can navigate between, or you could use the tabs. And we're looking also into the JavaScript API to maybe make this a little bit even more modern. If you go to the power curve dashboard for this project, let's see if this button works here. There we go. So now you're looking at a view of the operational efficiency of the turbine. So this is no longer what turbines are down, but this is how they're performing when they're online. And this is year-to-date view for 50 turbines at this site, Project A. And again, the black line here is the brochure power curve. This is how they should be producing. The blue lines are basically the average performance of each individual turbine. This view over here are alarms which may have affected the actual power curve and performance of the machine. So the one thing to note here, how I would take this specific project, is we have an issue at high wind speeds where most of the turbines are underperforming the black line significantly, right? And you could actually see through actions, if you wanted to look at E78, it had this significant event, and you can also kind of pair it up with the underperformance at high wind speeds. If you even wanted to dive deeper with actions, you can click a turbine. Let's see if there we go. So what I just did there is a kind of a pop-up view, and that will just filter out this turbine and this power curve, and will give you really all the individual data points which make up this binned curve. So this is actually really handy for engineers and for deeper analysis because you can truly see where you're having the losses, kind of at the knee of the power curve we're seeing, and you can also see even some scatter down here where this turbine might have some issues shutting down too soon. So we actually, when the wind gets too strong, we have to shut down the turbines because of loads. But if you see a lot of data points here where the turbine could be operating, it's also a classic signature that a parameter in the controller could be wrong. So these are the types of things that we would look at from a power curve perspective to try to diagnose problems. Another really interesting case in this site, let's see this action here. So down here is basically, we want to focus the user on what the worst 10 performers are. So this percentage is essentially how much electricity they produced relative to what they should have. So these are the worst 10 performing power curves on site. But we also allow the user to kind of toggle the selection. So they could choose the top 5 and bottom 5, they could choose the top, or they could choose the most changed over time, because that could signify a change point. For example, if you choose the top 10 turbines at this site, what you'll see is the number 1 turbine actually has some very crazy characteristics. So what you're looking at here is kind of an efficiency over time of the turbine, the green line being that turbine in question, so in this case E69, the orange line being the median performance of the rest of the site. So it's always good for us to make relative comparisons of one turbine versus all the other turbines at the site. So you can see that there's something that happened on this turbine where its performance just completely shot above the rest of the site on a day and then stayed above until it most likely was fixed. And actually, this is a really interesting case because this would then, when an engineer would be cued to look into this, because this is typically not physical. So this is likely a sensor on the turbine that perhaps has gone bad. The wind speed sensor has gone bad, and because of that, we're getting some spurious results. And actually, if you kind of scroll over the weeks in question here, that will pre-filter, again, the views. And you can see in this case, when we highlighted this whole region between when it was really not working that well and when it came back to normal, we kind of had this bimodal behavior where this was the turbine performance before and this is after. So there was something that was obviously fixed, and this would cue perhaps an engineering ticket for a lead fleet engineer to look at this issue and to dive deeper into the 10-minute data. So this is just a brief example of how we're using Tableau actually from a more an engineering standpoint, so we can really see the problems and try to fix them. So that's what I have for that. I have one other dashboard that I think I have time to show you. So those were more project specific, right? That's for an asset manager or a site manager or an engineer just to say, I just want to look at that project. I want to look at this time frame. I need to see my issues. I need to see what I can fix. But at a more executive level, when we're setting goals and need to see data, we need to roll everything up kind of into one bigger picture. So we've developed also some fleet-wide trackers of our projects, and this is one of them. So this is kind of pre-aggregated data in SQL, and what you're seeing here is a metric, one of our major metrics, which is called production-based availability. This is essentially another efficiency factor where it's the amount of energy we have produced relative to the amount we would have produced if it wasn't for all those reliability issues. So this is a year-on-year tracker, the blue being 2016 up to date, the orange being 2015 through the same time period. And you can see we're about almost 1% higher this year than we were last year across the entire fleet. That's about $2 million if you were to put a ballpark figure on it with the prices of energy we have. If you want to go back to all when we kind of started doing analytics and started using Tableau, this was 2013. So you can see there's been vast improvements, and we've gotten better year by year just by having more people looking at the data, which is the most important part first, but then having a slick interface like Tableau that people can collaborate on. So it's really made a difference in just sending the data over, like transparency, making people accountable, that type of behavior is also driven with Tableau. So I'll switch back to the presentation now. I only have a few slides left here. We can just watch some wrestling videos, I guess, if I run out of time. So success stories, I kind of just mentioned them there. So this year last year we increased the availability by about 0.7%, which was worth about $2 million. This year we're even higher than we were last year. So we're really excited about that. We've used Tableau to develop root cause, or to really do engineering studies and demonstrate that we've actually fixed a lot of problems with the power curves that you saw, some of those D rates with the turbines underperforming. We fixed about $200,000 worth of power curves this year already, so that's a big win. Also, for warranty claims, a lot of times when we procure a site at the beginning, there's a lot of infancy issues with the turbine when they're still under warranty from our providers like GE or Vestas or Siemens. And we use Tableau to really look at the data, estimate how much we might have lost because of those issues, and then go to the OEM and hold them accountable for that contractually. So we've been able to use Tableau as well to kind of crawl back revenue that we would have lost otherwise because of infancy issues and warranty issues. And finally, the one cool thing too is just by allowing the data to be more transparent and by enabling more people to care about it, you bring more visibility to how well you're even collecting the data to begin with. So it's a very hard process getting the data from our sites to our corporate network. And the first year in 2013 and 2014, we improved that process by about 4%. So we collected 4% more data than we did the year prior to when we started using Tableau and getting really deep into the data. Finally, I already showed you this demo. So finally, what's next? Lots of things, hopefully. We're developing now, and we already have kind of demonstrations of other dashboards for other technologies. Solar is also a big business for us. I didn't talk about it much today because I'm mainly a wind guy, but we now have prototype dashboards looking at solar plants that we own or operate across North America to do the same types of visualizations. You have different types of KPIs for solar, different technology, but we want to unify them in kind of one look and one feel and one product. We also are looking into using things like the JavaScript API better so we can make it maybe a more formal portal for ourselves rather than using Tableau Online strictly for anything or for everything. So there's a lot of other data connectors that we're looking to leverage for Tableau. And cloud adoption, so our third-party service offering, TrueAlytics, is leveraging Tableau Online. So we are using that a lot now, even compared to internal servers. So it gives you an idea of where we're going. I'm happy to answer any questions. I hope you guys learned some stuff about the ugly side of wind. It's still a great technology, but things go wrong, and that's why we need data to fix it. So thank you very much for coming, and I'll take any questions. Perfect.
This is, you mentioned SAP briefly, but how,
Yeah.
How are you planning using SAP data to create new dashboards? It's relevant for our work, what we do with cost, but there's a lot of different things like around the text going out there, doing jobs, how they spend.
Yeah.
What kind of analysis is being designed around that?
So we have some standalone dashboards that my buddy Chase here developed, and you can probably talk to him. But we ultimately need to track parts inventory. We need to track service orders for all the different times, like you said, the techs visit the actual turbine. And then what the ultimate goal for us is to kind of pair that. So for example, if there was a repair to the turbine, we'll have the operational data, we'll have the automatic kind of warnings from the turbine saying it's down, we'll be able to calculate lost revenue from an opportunity cost, and then we want to automatically merge that from the service order that would be associated from that repair and bring it all together in one dashboard. And I think the first thing we're trying is with Tableau 10, with multiple database connectivity kind of at once, to merge the SAP connection and the SQL Server connection into one front end. We could move try to move everything into one warehouse, but I think we're doing a more distributed look at it first, so we don't have to redo a lot of work, because we have thousands and thousands of lines of code and algorithms in SQL Server, so we might not just want to move them to another platform. So we're looking first to just kind of blend the data in Tableau and create that level of intelligence and evaluate how it goes. Yes, yeah, correct. So we have a central, we have two different things. So we have a more of a high resolution, an OSI Pi system, if you're familiar. It's a real-time aggregator, like a time series database, which brings the data all into one corporate environment. For Truelytics, we actually developed our own kind of aggregator where we, basically a lot of these sites have SQL servers on the actual site that have the 10-minute data that we need for this analysis. So we use SSIS, connect to each individual network, bring it into a central data warehouse in SQL Server, and then go from there. So what you're seeing today is mostly that, although we have some other possibilities as well.
For EDF's corporate customers that are engaged in BPPs, do you use Tableau in any way to get a sense of what their project performance is?
Yeah, so the question is, I'm sorry, I haven't been repeating the question. The question was, for external customers and investors, do we give them Tableau dashboards to give them an idea of how their project's performing? The answer is yes. So at any type of quarterly meeting, typically now we will probably throw together some type of either custom Tableau dashboard or go with one of our standard ones to show them. And like I said, also now with the cloud adoption, if there was a huge want from that organization to even look at that data daily updated on a server in real time, we have a product we could serve them up as well. Typically now it's more kind of the ad hoc quarterly or monthly meetings where we'll present stuff like that. Because yes, they will, I mean, it's a stock, right? Obviously you want to know how your stock's doing.
Are there any challenges for data integrity when you look at this type of a dashboard in the international market? So if you look at EDF's renewable projects beyond Canada and you look at the future of diversifying globally, what sorts of challenges would you see in maintaining this sort of long-term analytic structure?
So the question is, what type of challenges would you see maintaining this analytic structure when you're dealing with international projects all over the globe? And it's a good question. So yeah, there are data integrity issues. Even regardless of the international facet of it, there are a lot of data integrity issues with trying to retrieve all that data on site. You need to have a very robust QA system. You need to have validity checks to the data points to make sure they're not outside of certain bounds. You need to have data cleansing algorithms and all that. In terms of the international facet of that, we typically have stuck with North America, but we have integrated a few projects in Europe and haven't had too much of an issue. I foresee potentially going to the cloud will allow us to help distribute that load, maybe even across multiple servers internationally. So I think that's one of the potential solutions where if you leverage cloud technology, you can spin up a server here, you can spin up a server in Europe, you can have redundancy between them. So that's one thing that's kind of on our radar for that. And I would just like to say too, this is only like this is only more or less an engineering snapshot of the enterprise. We have other enterprise things going on at EDF, but this is really the engineering kind of focused effort that has been kind of organically grown over 2 or 3 years from just kind of needing to do our jobs. So there's other larger EDF initiatives with that type of kind of corporate network that are ongoing as well. Yeah. Yeah. So from a Tableau employee, what challenges have we had? Large extracts. They suck? No, they don't suck, but they need work. I was excited what I saw today. So we had a lot of problem initially, and we're still working on getting extracts from on-prem data to the cloud. Data sync was failing a lot. So we actually reorganized our data structure and our schema a little bit to kind of work around that. But if we had truly like extracts that were more optimized for hundreds of millions of rows, that would be awesome. Because that's kind of the level of this data can be that. Our major BI table is about 1 billion rows at this point, so and that's only about 3 years worth of data. I would say extracts are number one. It's a pretty good product. I mean, it's a great product. It's just there's a few things like that we would definitely like to see. Oh, yeah. Yes. So radar plots is, we have this major view that we just create customly called a windrows. So it's a distribution plot of wind direction. And Tableau does not support that as a custom view. And we always get queued by our asset managers, where's my windrows? Where's my windrows? And we just can't make a radar plot. Well, we could, but we'd have to really hack it. I'm done hacking Tableau. I just want to see it as common features. Once I did the pop and swap, I'm done. Like that's the biggest hack I'm going to end. And the question is, any challenges getting people to use the dashboards? Yeah, I mean that's the biggest challenge. That's the biggest challenge, and there needs to be hand-holding. There needs to be. The one thing we try to do too is with the tooltips at least provide some like on-screen documentation. Which is, will at least allow them to kind of visualize what they're seeing. But it's incredibly challenging, especially in this type of data, which is more sensor data, to really convey it to a non-technical audience. So yeah, absolutely. At first we had a lot of issues with adoption outside the engineering group, and we still do. We still do deal with adoption issues. But that's just, that's a process. That's documentation. That's training. That's people liking using the tool. And I think we're really getting there, where even some of our asset managers now want to start designing their own stuff too, which is good. Yeah, so that's actually the one also thing I didn't mention to help visibility. Yeah, we kind of taught our asset managers to set up a subscription so they get a daily email, because we still run on email as a company mostly. So, subscriptions have helped. Yeah. Are you did you develop the subscriptions? Yeah. No, it's nice. It's really nice to bridge that gap because people still want to look at their email, right? So, I try to show them like you can just log into the server, you can click things and play around. Like, no, just want to see my email. No. Yeah. I think it's happy hour now. They usually start serving beer at 3 on the side. So. Cool. Thanks, guys. I appreciate it. Thank you.